Everybody says GPT 5.6 Sol is the most efficient flagship OpenAI has ever shipped. I spent weeks running it through its boldest claims to see if that's actually true. GPT 5.6 Sol claims elite coding, token efficiency, and rock-solid instruction following, and I want to see whether the evidence backs that up or just exposes the hype. One of the biggest problems I run into when using AI agents is turning their output into YouTube content I can actually use to market my product. That's why this video is sponsored by Subscriber, a tool that helps business owners connect their AI agents to YouTube and market their products without spending 10 hours every week creating content. You can connect Claude or ChatGPT directly to Subscriber. It then analyzes your business, website, and YouTube channel to help you create SEO-optimized video ideas, scripts, thumbnails, and even complete videos that actually match your brand. What I like most is that every week, Subscriber gives me a list of high-potential video ideas I can immediately execute, and it can even help edit videos for me, with or without my face, including videos like the one you're watching right now. It's easy to get started, and you can try Subscriber for free using the link in the description below. Now back to the video. Claim 1, Token Efficiency. OpenAI prices GPT 5.6 Sol at $5 in and $30 out per million tokens, and they say it's efficient. But the objection I keep hearing from real users is this. You're on a $200 monthly plan, you sit down Monday morning, and by Tuesday afternoon, your weekly limit is already gone, and that's not a pricing page problem. That's a token burn problem. I cross-referenced the official pricing page with community reports, and the gap is pretty stark. Users on $200 monthly plans are reporting they burned through their entire weekly allocation in hours, not days, and the per-task cost balloons because the model consumes tokens at a rate the official specs just don't warn you about. This charge sticks. Real-world token burn directly contradicts what the pricing page implies, and that's 0 of 1 claims holding up so far. So if you're building anything at scale and counting on predictable costs, GPT 5.6 Sol's actual consumption patterns are going to surprise you in a bad way. I only know how bad that token burn gets because I've lived inside these tools long enough to watch a budget evaporate in real time, so drop a comment below if the token wall has caught you off guard too. Claim 2, Coding and Agentic Ability. OpenAI says GPT 5.6 Sol is the best model for autonomous backend work and shell tasks, and a developer shipping a production pipeline on a deadline needs to know if that's actually true. Because if the model stalls or hallucinates mid-task, you're not just debugging code, you're rebuilding a broken agentic loop from scratch at 2 in the morning. The leaderboard numbers are pretty hard to argue with. SWE bench verified at 96.2%, Terminal bench 2.1 at 88.8%, Browse comp at 92.2%, all measured scores from Vellum's leaderboard, and the community backs that up for shell and agentic tasks, though they also call it, and I'm quoting here, linguistically an idiot for explanations, so the coding muscle is real, even if the communication isn't. This charge is dismissed. The coding and agentic claim genuinely delivers, backed by top-tier benchmark scores across 3 measured tests, and that puts us at one of 2 claims holding up, though I'd note that elite execution and clear explanation are 2 very different things, and GPT 5.6 Sol only has one of them. Claim 3, Data Extraction Efficiency. The claim is a 23% cost reduction over GPT 5.5, plus better field recovery across documents. And that number matters a lot if you're running extraction pipelines over thousands of pages, because at that scale, even a modest cost drop is real money. But a number that doesn't survive real workloads is just a marketing slide. I dug into the community-reported numbers, and here's what actually came back. 23% cost reduction versus GPT 5.5, field recovery up 0.6 percentage points, and cross-page reasoning up 11.8 percentage points. And while these are single-source community reports, so I'd treat them as directional rather than definitive, the direction is consistent, and that cross-page reasoning jump is genuinely big. This charge is dismissed too. The data extraction claim holds up on the community evidence we have, which means 2 of 3 claims are now confirmed, and the cross-page reasoning improvement is the standout finding, the kind of gain that actually changes whether a pipeline is worth running. So coding and data extraction are looking solid, but we still have instruction adherence and one-shot generation to get through, and those 2 are where the community reports get really messy, because how the model holds up under a long, detailed prompt is going to decide whether any of those capability scores mean anything in a real production run. Claim 4, Instruction Adherence. OpenAI says GPT-5.6 Sol follows prompts 60 to 70% better than competitors, and the failure mode that actually costs you is this. You write a detailed system prompt, you run it for 2 weeks in production, and the model just starts ignoring it. Mid-session, no warning, no error. Just a completely off-script response that breaks your entire workflow. I ran this one twice because the numbers are so far apart. Community reports say adherence is 60 to 70% better than competitors when it works, but one user documented a 98.8% failure rate over 2 weeks where the model lost frame and ignored the prompt entirely. And that spread is so wide, it basically means reliability here is a coin flip, depending on your specific setup. This one partially sticks. Instruction adherence is real when it works, but the loses frame failure mode is documented enough that you can't count on it. So we're at 2 of 4 claims confirmed, 1 partially true, and if your workflow depends on the model staying on script for hours at a time, that partial is a real problem. Claim 5, one-shot generation and aesthetics. The claim is that GPT-5.6 Sol produces polished, on-target output on the first try, better than other models, and the failure mode is subtle but expensive. You ask for something specific, the model delivers something beautiful, and then you realize it also added a bunch of stuff you didn't ask for. Burning tokens and your review time in the same pass. When I dug into the community reports, one-shot output quality is genuinely top tier, outperforming other models on raw aesthetic quality. But the autonomy problem is real. The model over-engineers and makes decisions that are irrelevant to the actual prompt. So you get great output, plus a pile of unrequested extras that cost you tokens and review cycles. This charge is dismissed. One-shot generation delivers on quality even if the over-engineering is a real friction point. And that lands us at 3 of 5 claims confirmed. 1 partially true, so the final tally is this. A GPT 5.6 Sol holds up on the capability claims and stumbles on the reliability and efficiency ones. Alright, so where does GPT 5.6 Sol genuinely shine? Backend and shell coding is the clearest win, with a 96.2% SWE bench verified score that's hard to argue with. One-shot generation quality is top tier, and for data extraction pipelines, the cost reduction and 11.8 percentage point improvement in cross-page reasoning are real. Documented gains that show up in actual workflows. And I'm not going to soften where it falls short. Token efficiency is a real problem because users on $200 monthly plans burn through weekly limits in hours. Linguistic clarity is poor enough that the community literally called it linguistically an idiot. And instruction adherence is inconsistent enough that you can't trust it to stay on script through a long production run. Worth it if you need a powerful autonomous coder and you can actively manage the token burn, but skip it if you need consistent, budget-predictable, prompt-faithful behavior across long runs, because 3 of 5 claims held up and the 2 that didn't, cost control and instruction reliability, are exactly the things that decide whether a production workflow survives contact with the real world. One thing the marketing page won't tell you. The 128K max output cap means that on very long, agentic tasks, the model can hit its output ceiling mid-run and return a truncated result with no explicit error. So your pipeline silently gets incomplete output, and you don't find out until you're reviewing what looks like a finished job. If the token burn question got you thinking about cheaper alternatives, I did a full breakdown on DeepSeek V4 Flash versus Kimi K3, asking which is actually cheaper, and the answer is more interesting than you'd expect, because the winner actually flips depending on your usage tier, so that one's worth checking out next.